But as we start today on our statistical analysis, we're going to start with some basic stuff, hopefully some things that you've even heard of before and dealt with. The little symbols that I have here on the side are going to be things that we're doing with the graphing calculator, so you can just kind of have a reminder of what those symbols look like. Mean, again, is just a fancy word for average. Okay. But we want to start taking a closer look at when's a good time to use all of these things, depending on the data that we have. So for instance, here, the key is that there's going to be no outliers. Not an outlier, let's see. No, that isn't when somebody tells you a fib and you scream, outlier! That's not how this works. It's more of, is there a number that's out of whack with everything else? Is there a number that's out of line from all the rest of them? That's what we're on the lookout for here. For instance, if you were looking for an example of an outlier and you were looking down at example 1, 2.1 might be an example. I don't have to do this often, but hey, thank you. But 159.4 definitely would be, because that's way away from all the rest of them. So we wouldn't want to use mean for that one because it would kind of get thrown off by that value that's out of there. Median, the middle number, the mean of the two middle numbers, if you don't have a single one, in ordered data. In other words, the numbers have to be in order from least to greatest in order for you to be able to find the median. If they're all mixed up, you have to put them in order first. But again, here, you can deal with outliers, but you just don't want to have a big gap in the middle of your data. So like if there's like a 50 number difference between the middle two numbers, median may not be the best idea for you on that one. And then mode, there's not a specific place in the calculator, but it's the number that occurs most often. The eyeball test works well with this one. And again, the data can have many numbers that are repeated. Stressing many. At least 2, preferably 3 when we can. And then we're also, when we get a little further, going to look for this thing called the margin of sampling error, which is 1 over the square root of n, but out of n items. So if I survey 400 people, I'd stick in 400 for n. Okay. If I was surveying 127 people, same thing. And it'll let us kind of estimate how well that population's going to be. These come up a lot during election time. You'll see, oh, this candidate's 51% approval rating plus or minus 3%. Well, now you might actually be able to start figuring out how many people they actually surveyed before they put that data up. So here's how this is going to work for us. Which measure of central tendency best represents the data and why? Well, we already talked about this for a minute. There's an outlier. So mean, bad idea. What might be my better option here? Because again, margin of sampling error isn't a measure of central tendency. It's just those 3. So between median and mode, which would be the better option? Median, because mode, I'd have to have repeats of values. I don't have any repeats. So here, the median would be my best representation of the data. Where again, if I was going to calculate it, I'd just work my way towards the middle. And in this case, since there's 2 middle numbers, I'd add those up and divide by 2. So it'd be like, my median in this case would be 22, bless you, 0.55. Because I'd take the mean of those middle 2 values. To get a little feel on margin of sampling error, kind of going along with the example I talked about a minute ago. Likely interval that contains the percentage of the population. Of 400 people surveyed in a national poll, 51 say they will vote for candidate Gonzalez. So since 400 people got surveyed, our margin of sampling error is plus or minus 1 over the square root of 400. So, of course, probably don't know that off the top of our heads. So I do 1 over the square root of 400, and that's where this 5% is coming from. Plus or minus 0.05, which we know represents 5%. So what that means to us then is that 51%, if there's a 5% margin of sampling error, I would subtract 5 from the given percentage, and I would also add 5, and that would give me my range or my interval of what will probably actually happen based on that. The more people you have to base off of, the smaller the error is going to be. But if you only survey like 5 people, you're going to have a whole lot of error. So just something to consider. So which measure of central tendency best represents the data and why? Okay, what about for number 1? Which one would represent mean, median, or mode? Mode. I have 345s. Those 345s can also be called a modal value. Whatever number gets repeated a whole lot gets called that sometimes, if there's a little language issue every once in a while that might get thrown at you. What about number 2? Median. Why median? We have an outlier. Once we get that oddball in there, mean goes out, and as soon as I don't see any matches, like I did here, mode leaves too, so it makes median pretty straightforward, the answer. What about 3? Median, because we have another outlier. And finally, number 4. Mean. Some of you may say, well, 44 is kind of out there, but it's not like way out there like some of these other ones have been. So I have to watch for that a little bit. Make sure we get that set. And then one more here, sort of like our candidate Gonzalez from up above. We have 28 random people that found 40% read at least 3 books each month. What's the margin of sampling error, and what's the likely interval that contains the percentage of the population that reads at least 3 books each month? So again, I'm going to take my number of people being surveyed. So I'm going to take 1 over the square root of 28. And typically here we go to the nearest whole percentage. So in this case here, that's going to put us at about 19%. If you've got more specific, I wouldn't call it wrong if you did like 18.9 or something like that. But then since it mentions that 40% read at least 3 books each month, I'm going to take that, I'm going to subtract it from it, and I'm also going to add it to that and find out, wow, when you don't survey a whole lot of people, there's a whole lot of margin for error. That 40% could go all the way down to almost 20 and almost way up to 60. So maybe I better survey a few more people before I get going along too far here. And then our only other deal for today is going to be talking a little bit about standard deviation. Now, there's these big fancy formulas. I'm not a big fan of actually having to use them, especially when we have technology available to be able to help us out with this. So, we're going to try to figure out if something's a sample, part of a group, or a population, the whole group. Because how we determine their standard deviation depends on which way that we're going to do that. So, when we take a look at our example down here, we have test scores of 12 students in a college math course. Is that going to be a sample or a population? Sample. Because we only have part of the class. It's not the whole class. So, like it says, because the 12 scores are given, now that's just funny to me, this is a population. I don't think so. But unless we found out there were only 12 students in the math class, then we could call it a population, but I still think sample's a better idea. So, who on them? So then, find the mean and the standard deviation. So, okay, here's how this is going to work if you are going calculator world, which is a very good idea for this. If I showed you how you would have to calculate this by hand, you would see why I want to do it this way. So, here's how we're going to do this. We're going to go to the stat button. We haven't played with this one yet. Over here, and we're going to edit the list. And I'm going to assume there's probably going to be information in your list unless it's your own calculator. If there is information, instead of having to delete every single one as you go piece by piece, if you arrow all the way up to the top of whatever your first column is, yours, if it's in here, it may be L2, L3, L1, doesn't matter. But go up to where that L whatever is highlighted. Hit clear. Now, it won't look like it's done anything. But if you arrow back down, then it'll go away. Right up here next to where that arrow is up there. And then we want to edit. So once you hit stat, it's that very first, and then edit. We like that. And if you have stuff again, just highlight whatever the L number is, hit clear, and then come back down. You should be cleared then. And what we're going to do at that point is we're going to take these numbers and sort of like putting them into a adding machine or something like that. I'm just going to keep typing in the numbers that are in my chart and hit enter until I get to the end. Now some of you may say, if these lists get kind of long, what's going to keep me from possibly making an error? Now, there's not a way to make sure we don't make an error, but there is one nice tool that this calculator gives us to kind of help make sure that doesn't happen. You'll notice at the start of the problem they talked about there being 12 students enrolled. If you get to the end and you look at the last number you typed in, you'll notice the calculator's nice and it'll put 12, 10, whatever your last value was. It'll tell you how many values are. Oh, I typed in 12 numbers. I feel pretty good, unless I hit the same one twice. So I can get those all in and I've got my list ready to go. So once I get the list, okay, we're going to go back to stat. This time though, when I go to stat, I'm going to arrow over one to the right to calc. And we want to use number one, variable stats here. And here's how this is going to work. You're not going to think it did much here at the beginning. You hit it, okay, now what? I need to tell it what list to look in. So, if at the top of yours it was L1 before, you would hit second and 1. It'll say L1. If your list up at the top said L2, you'd hit second and 2 for L2, whatever it happens to be. Once you get that and then hit enter, all sorts of fun things should start happening. You're going to be given more info than you could use right now. Let's break down for a second, though, what that info actually is and make sure everybody's on the same page with this. The mean is the x with the line over it. Oops, let me move my calculator over here. So my mean is about 81.4. Now, the standard deviation, this is where I've got to be careful. If my standard deviation is for a sample, that's when we use the one that looks like the S here. If we had it for an entire population, then we use the one right below it. So they're real close to each other, but I have to pay attention to those things. So in this case, since in this case we went with that this is a sample, oops, we're going to use this one. And get our value. So I can do all the right things, but if I don't use the correct one, that can kind of get me into trouble a little bit. So be cautious, be cautious, be cautious. Issues so far. All right. So then we're just going to do one more of these, and then I think we're in pretty good shape. This first day is not too bad. We get to play one more time here. All right, determine if this is a sample or a population. Then find the standard deviation of the data, round to the nearest 100. All right, is this one going to be a sample or a population? Sample, because we got some. So we're going to run through this process one more time. Move this over here so I can see all my numbers. All right, so back to stat. Again, we want to edit. And I've had people say, well, what if I just want to leave the first list? Can I? Can I just arrow over to L2 and use it? You could, but I don't want to keep my other list right now. So I'm going to clear that first list out, again, by going up and hitting clear. And then I'm just going to type these guys in and do the exact same process that we did on the first example. And again, when you get done, you might want to check and make sure that your number of values is the same as that little number in the parentheses that the calculator is so nice to give us. I notice we got 12 scores we're working with again. My 12's there, makes me feel good. Once that's in, again, we go back to the stat menu, over to calc, there's our variable statistics. And again, I'm in L1, but again, any list will work. Just hit second and whatever number's up at the top. For mine, it's 1. Roll that through. There's my standard deviation for my sample. And I get that, and I am good to go. But again, if it were the whole population, I would just use the one right below it. Questions? All right. So you can fire away at some of that book work, or maybe a final review, or maybe if you've got something to still finish on the homework check for some reason, you can